Now the next question says, state three observable phenomena in which wave behave as particle. Now we want to look at some of the properties that make us say that wave has a particle nature. So let us look at it now. Number one, we are going to be talking about black body radiation. Now, black body radiation is the radiation or the thermal electromagnetic radiation that is usually around a body that is in what? That is in thermodynamic equilibrium with its environment. So if we want to talk about what thermodynamic equilibrium is, it's going to be a long thing, but for us to just understand, a body is said to be thermodynamic equilibrium with its environment if it maintains the same temperature, it maintains the same chemical composition, it also maintains the same mechanical energy or pressure during that specified time. Now you must understand that black body radiation takes place only with black bodies. That is, that black body is going to be a non-reflective body. It's an ideal body. It does not reflect light, or it does not reflect any ray that is incident on it. You might ask that if these black body radiations really exist, why can't I see it in dark places? The reason is because the radiation that is usually around these bodies is beyond is beyond the visible spectrum of light. This is the infrared spectrum, and so it cannot be seen even if this very radiation is in the dark. Now let's go to the second thing we have to talk about. We want to talk about photoelectric effect. That's another proof that wave behaves like particle. What is photoelectric effect? Photoelectric effect is a phenomenon that is used to describe the emission of particles from the surface of a material when they are hit by light or other electromagnetic waves. So when the surface of a material is hit by light rays, they emit electrons. That is what photoelectric effect is. One of the ways in which you can be able to detect the wave and particle duality of light. So that is one of the proof. Number three now is the Compton effect. Now, Compton effect was discovered by US physicist Arthur Compton. He discovered that when high energy photons or other electromagnetic waves are scattered by electrons, their energy is reduced, and correspondingly their wavelength increase, and while the energy of the electrons are increased. So this is what we call Compton effect. It's another way of proving that wave has nature of particle. Do not also forget other wave properties such as reflection, refraction, diffraction, polarization, and interference. They are also one way you can be able to determine or detect that wave is a particle or has particle behavior.